All right.
Davidson,
Yes.
did I make something? Did I make whatever they're called?
Oh, you made a molecule.
Did I do it?
I mean, no, but it looks cute.
It looks like a
Okay, I have for you on page 7. Please turn to page 7. I don't know where I put that. Oh no, I'm in trouble. Probably, nope. All right, at the bottom of page 7, I would like you to write these 3 sentences right here on the board. I guess that's 4 sentences. You're going to complete these sentences using that word bank. I believe you can do it. I'll get this going. All right, then first hour, I didn't have my audio on, so I'm going to be recording during this class. So I'm going to repeat what I just barely said here in a second. Oh, I am recording. So what we're trying to do, and I know if you're watching this video at home, which 6 or 7 of you may, I know that you can't see the word bank. We'll work through it together. The word bank is lose, gain, ionic, anions, cations, loser, ions, positively and negatively. What's that? Loser is pronounced Mr. Burt. Is that what you said? It is. I agree. You're welcome, everybody. Little ASMR action right there. I apologize. I swallow loudly. How's it going? Good. How we doing? That's page 6. Okay, that's just being funny anyway. Annoying. I am a very intimidating person. I'd be a great protector of people. Is there? There's no way he's gonna say yes. That's closer to a yes from him. Can he be asleep by 8:30? He is a baby about sleeping. Like what adult goes to bed at 8:30? Okay. How does your dad? He has meetings till 10 every night probably. He sleeps in his meetings. Oh, I get it. I'm trying to develop that skill myself. A really nice mattress, and I have to have someone to snuggle with besides Jessie. Her name would be Melanie. And then probably my little Carly Jane. Got to bring my daughter. No, no. Are we ready? Tell your partner what this sentence says. Ready, set, go. Tell your partner what it says.
I only got one word.
Which one?
Loser.
Loser. That's a good start.
And leaks. So I got 2 words.
2 in a row. That's 2 for 2.
Is it possible?
Nice. I believed in you.
I'm getting there.
All right, friends. Here we go. Will anyone be offended if I teach with my feet up on a desk? Thank you. Here we go. A metal is a loser. Who had that? Thumbs up or hands up? Sorry. Metals. Micah, did you get it wrong?
No, that's not me.
Oh, okay. Okay. That's fair. I understand that. Metals lose electrons. Oh my. To become, I don't want to write positive, so I'm just going to put a plus sign. Are you okay with that? Positively charged cat ions.
I thought you said you couldn't sit there yesterday.
Well, you haven't been mean to me yet.
I wasn't mean yesterday either.
You're right. I'm sorry. All right. Who had that whole sentence correct?
Me. I do now.
Oh, nice. All right. I do now. A nonmetal will gain electrons to form negatively charged anions. So far, okay?
Yeah.
Awesome. When a bond happens between 2 ions, we call it an ionic bond. If I put those sentences on a test with a word bank, could you do it?
Yeah.
It's not that bad, is it?
No.
Okay, I'm thinking about putting it on there. It's not on there yet, but I think it's reasonable. What's that? Mix it with something harder.
Please don't.
Well, what I would do, and it's just, I'm just thinking about it, is the test would have 3 questions. This would be the first one. The second one would say, when 2 nonmetals bond, they form a covalent bond, or like it would be a covalent. And then we would talk about metallic. That's kind of my idea. What, did you ask me something?
I did, but not relevant.
Okay. By the way, the email never says what time. It just says 1:20. That's fine. Whatever you need to do to stay safe. That's my number 1 priority. Okay. Now, one more question here. Let's pretend that I have gas. Also known as gallium sulfide. All right. I never grew up. All right. Junior high was just so great. I wanted to stay there forever. Just kidding. That was actually not.
That would be the worst place to stay.
Yeah, it would. Well, okay.
I hate
My dad wasn't the principal.
true that.
All right. Will you tell your partner if we have gallium sulfide, what these 2 numbers would be? Ready, set, go.
Okay.
You got this. I know you know.
So would that be the 3? Is that sulfide, right?
Right?
Right. Okay, -2. So then it's switched.
Nice.
So it wouldn't be the negative. It would just be 2.
You don't
It
take,
doesn't-
yeah,
It doesn't count the negatives, right?
perfect.
It's 2 and 3.
There you go. She's going to teach you. Awesome job. What do you get? Nope. Yep, 3's right. Don't ever take,
So would there not be anything there?
no, there would be. There'd be a 2, but not a negative. All right. Are we ready? Ready? Good stretch. How are you? Oh, that felt good. Okay. What we would do is we would find the charge of each one, plus 3, minus 2, then we would drop them and swap them. Don't ever take the negative or positive sign. Ga2S3, that's how we'd get gallium sulfide. Thumbs up if you're all right with that. Okay. All right. Cronin, you're down? You're down lower on your feed. That's where you are. Oh. Okay. Wow. Okay, moving on. So we feel all right about that? Okay. We will do more of these, but today we have a little activity called spheres and sticks, I believe, right here. This is on page 13, if you would turn there. In this activity, we're going to use these little things, which have just gotten demolished over this last week, but whatever. We're going to make models of atoms, and we're going to draw them. We're going to label them. We're going to do all sorts of things so that we can get a little bit smarter about ionic bonding. Sound good? Okay, so turn to page 13. Let me turn the lights on a little bit so you can see the spheres a little bit better. They are not. That'd be they'd be really sticky. I've had these same ones my entire career, and I bet they were made 10 or 15 years before that. So this is loud. Yeah, I'm old. What's that? Yeah, they were incubated here, then I mailed them to China in a conspiracy to get Trump not elected. So, dang it, you've exposed me, you QAnon people. All right, so you'll come and grab a bag, and it will have all sorts of stuff in here. They're really disorganized, but they should look something like that. A green is one of these wood spheres with one hole in it, and it represents something that's a -1. So what this is really representing is a non-metal that needs 1 electron to be happy. Fair enough? All right, a red, it has 2 holes. It's representing a non-metal that needs 2 sticks to be happy. All right, and then yellow, right? That has 3 holes. That's representing a non-metal that needs 3 electrons, or like a -3. Then we have the ones with the actual sticks. So this gray one is in the middle there. It represents a metal. Look at me for a second. It represents a metal with 2 electrons that it can donate to one of these that has a hole. You all right with that? So we're pretending the sticks are the metals, the ones with the holes are the nonmetals, and we're going to make ionic compounds. So when we make ionic compounds, it has to be a metal and a nonmetal. So today, you'll look at your periodic table and you'll think, oh, I'll use hydrogen as my first one. Don't ever choose hydrogen today because that's a nonmetal. We need it to be a metal. Okay, black, that's the one with 3 sticks or 3 extra electrons or something from family 3. And then is it white, right? White has just the 1. Easy enough? Okay, so what we're going to end up doing is we're going to make models. So for instance, well, let me read the directions first, and then it will make better sense. So it says use no more than a total of 5 spheres in your models. So that's why Micah, you just had a problem. I had like 15. All right, so we won't have all these make one thing. It'll be much more simple than that. Then a given model will have only 1 color of sphere sticks and 1 color of sphere holes. So there'll never be more than 2 total colors. So like this gray and this green, they can go together. It's 3 things, but only 2 total colors. All right, next. Each hole on the sphere holes must be filled with a stick, and each stick must be placed into a hole. Did you hear that too? Yeah, I did. Yeah, That's some Burger King onion right there. Okay. I'm just gross and awkward, okay? At least you're not. Yeah, well, you're welcome. I try and make everyone's life more awkward. Yeah,
You're doing a good job. In a good way. You are.
you're all welcome. I'm here for you. Okay. So what that is saying is I can take this model and I can put a green on it, and that will fill the greens one hole and it's happy. But would I be done? No, because I have this stick hanging out. So just like in chemistry, something that can donate 2, but something that can only take 1, we need 2 of the 1s to every 1 of the 2s. You okay with that? It's the same math little mumbo jumbo I did yesterday where we made sure everything was neutral. So this will be neutral, and we'll see why in a minute. Okay, so I've made this model, and we'll talk it through here in a second. All right, it says do not remove the sticks from the spheres. That's too late. There's sticks and spheres everywhere, but when you do the lab, we'll have the chart up there and ready. Okay, next, let's just do this. Hold on, I got to get rid of the answers here. Whew, that's close. So we're going to go to the table and label +1, +2, +3 in the columns, and -1, -2, -3. So +1, +2, +3, -1, -2, -3. Okay. If these are plus signs, then the column is representing a metal from family 1, not hydrogen. Choose a metal today. This column represents a metal from family 2, and this from family 3, and it will make sense, I promise. I see some confusion, but it'll work. Then across -1, that means I'm having something from family 7, something from family 6, and something from family 5. So when we use that thing we labeled yesterday, like the charges, it will help us put this all together. So this right here, if you remember, that wasn't me. Okay, if you remember, this was something with 2 sticks combining with something with 1 hole. Will you point?
I'm so sorry.
It's okay. Will you point to the square on page 13 you think you're going to draw this model in? Point to the square where you think you're going to draw this model. That's a very nice drawing.
What is it?
It's a +2.
It's the thing with 2 sticks with 2 things with 1 hole. Well, it's one of those 2. You are right.
You're a genius.
I'm scared. We are 50-50 right now. All right. It is this one. It's okay. The directions said that the sticks represent +1 or +2, and the holes represent minuses. We should have read the directions. Okay, so we're going to draw this model in that box. Just stick with me. We can do this. So don't draw it like huge. Don't draw it tiny. You got a lot of stuff to put in there. It's okay. You can fit it all in there. You'll be fine. Okay, so I now have my model. Then I'm going to keep on following the directions because Maddie says it's helpful. All right, so I labeled, I made it, and I drew it. Label the circles that represent the sticks, +1, +2, or +3, and the circles that represent the holes as -1, -2, -3. So I come over here, and I'm going to put a plus 2, and a minus 1. Now, if your circle's not big enough, you can certainly write it on the outside of the circle. It doesn't really matter. Okay, good so far? Okay, every time you make one of these models, those numbers have to add to 0. That's one of the major points of this whole assignment, this activity. They are always neutral. So I have 2 minus 1 minus 1. That's 0. Rocking it. I got it. Okay. Next piece of instruction says 2. Choose a representative element for sphere sticks and one for sphere holes. This is where you'll use your periodic table. Find me, someone tell me their favorite metal from family 2. Calcium. All right. So I'm going to put a Ca right here. How did I know to look in family 2? Plus 2. It's on my periodic table. My plus 2s, I will always choose from family 2. Then, where am I going to look for a minus 1? In the minus 1 family, but that has a different name. Family 7. I don't know. Fluorine, okay. So I'll choose fluorine. You can put an F and an F. C, A, F, and F. Okay, now I go back. It says, using the representative elements, write the formula. Okay, not too bad. We always put the metal first. So I'm going to put Ca and then an F, and I needed 2 of them. So CaF2. Fair enough? Okay. Is he jamming? Is it Christmas? Is it Disney? Is it Christmas? It's a commercial. I was so excited. That is, well, Mikkel Hansen would say that's Godard's room. That's probably one of my favorite moments in time. When she called him Godard. I'm like, yes. Okay. Yeah. The next piece of instruction, I'm not going to turn there, but it says to name this substance. The name of this, you name the metal, that's calcium. Calcium fluoride. So fluoride. Now, this is a tiny bit tricky at the end. Whenever we write the name of an ionic compound, it always follows the same format. It is metal, non-metal, ide. So you've heard of fluoride before. This is actually the exact stuff we're hoping you form on your teeth by using fluoride. You make your enamel stronger by getting calcium fluoride on the outside. Fluorine or fluoride is so reactive that calcium fluoride stays bonded together and it's white. That's what we're looking for. Okay, anyway, other non-metal endings, just so you've at least heard them once, would be nitride, oxide, fluoride, chloride, bromide, iodide, sulfide, and phosphide. So if you choose any of those somewhere else, those are your endings. Now, if you write it wrong, like phosphorus-ide, you're not going to get it wrong. You just put too many letters for fun. Okay, now the last step here is to draw the dots. Okay, so we have enough space to draw the dots, Micah? Yes, all right, so the dots are always pretty simple. You take the one you have the least of, which is calcium, and you put it in the middle, and the thing you have the most of surrounds it. And then the non-metals always get 8 dots. And the metals always have no dots. You need that bigger? I'll draw it bigger. So F, C, A, F, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's the dot structure. The metals always have 0. The non-metals always have 8. And I just realized I didn't give you the hint you're going to need to do the hard ones. So if you're done with that, raise your hand if you're done with that square. Okay. I meant to, when we talked about gallium sulfide, I forgot to draw the dots. Today, in 2 of the boxes, you'll have one that has a 2:3 or 3:2 ratio. When you draw these that have 5 total things, you take the thing you have 2 of and you put it on the top and on the bottom. And then the thing you have 3 of, you put it in between. It's like a sandwich, okay. And then the non-metal gets 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The way that the non-metal got 8 is gallium gave one here, here, and here, and there, there, and there. So we end up sort of with this pyramid structure, or sandwich if you feel like it. Okay, you'll see that structure in 2 of these boxes. So try and figure them out, try and build them, and you'll be good. Okay, now these 3 boxes right here, they all look really similar. They're different, but they look very, very similar. When you get to these, this one and this one, don't overcomplicate your model. Nature always seeks the simplest ratio of atoms. Okay, now at least half of you are probably confused, but that's fine because you're going to get in groups of 4 and work through this. And the odds that at least 1 in 4 of you know what you're doing is pretty high. Now, when you grab a bag, what's that?
You just jinxed us all.
No, you'll be fine. Find the kid that maybe doesn't get an A, but is really good at hands-on stuff, because they usually slay this stuff. All right, when you grab a bag, and this one is just exploded. Like, this is like 5 bags. Just grab it. You can go to a station and work. You can come back to your desk and work. It doesn't matter to me. Nobody work alone. That's a waste of your time.